Well, thanks for having us here. It's a wonderful campus and a really nice experience. And of course, all of us are happy, whoever is from the East Coast or any place else with snow. It's just fantastic to be here. Okay, topic of the discussion is assurance cases and test design analysis. It's part of a larger study, and I worked on the test design analysis last year and then moved on to other assignments. But I do want to keep the assurance cases topic in front of the community, so I would welcome any kind of feedback, input, to enhance the work or carry it on and apply it to other domains as well. Scope, this is the outline. I just want to mention test design challenges and then assurance cases. After that, there are a few examples, and here is the result from this, and then summary and conclusions. Due to ITAR, I just picked up an example about automobile case study, and it turned out that it was pretty relevant because JPL, perhaps one of the leads on JPL, they actually did some analysis for Toyota software issue as well. So if you guys remember, a couple of years ago, Toyota had huge issues with their unintended acceleration. Okay, I just want to make sure that I give the credit where it is due. It's not all my, not my work. It's just a small part, the test design analysis. But there was a much larger study done for the risk assessment, and it covered other aspects, other stages of the software design lifecycle. And the work was done last year, and right here, the one where we are talking about is the test design analysis. There's a term over here for COM. This is specific to IV&V facility, catalog of methods. And as far as acknowledgement is concerned, right here, there are other centers and other team members who are involved in it. And then, of course, I, like many of us, was able to use the eval copy for the ASC tool and kind of see how well it fits. But guess what? After trying different tools, I ended up with the most wonderful analysis tool that we all have access to, right? It's called Microsoft Excel. Mm-hmm. And I'll explain why. I mean, Excel was much more useful in this case because we ended up doing some combination algorithm as well in there to come up with a better score for different assurance cases and all. Okay, so here is the test design V&V. So what do we have? Well, we get a bunch of test artifacts. So how do we make sure that these tests are covering the scenarios which are based on 3 different aspects? Okay, so in our facility, we are using 3-question approach. I'm sure you guys have all heard about that before. The first one is the nominal scenarios. And what are those? Basically, what the system is supposed to do. The next topic, the next aspect is the off-nominal scenarios, and we divide them up into 2 different questions. The first one is what the system is not supposed to do. And if the third question is that if something goes wrong, can the system handle it? Okay? So those are the nominal and off-nominal scenarios. So we want to make sure that the test design is covering those 3 specific aspects. Okay. Here is just a reference, DO178B. It's around. You guys can download that and see. Here we're talking about off-nominal test designs. And I'm going to go through these slides relatively quickly because I was told that since we can finish this early, we can go ahead and enjoy our time at Dave & Buster's. But feel free to stop me and I can answer any questions. You guys don't have to wait until the end of the presentation. So possible inputs for test design analysis. So we are all familiar with them. we usually have access to test plan. That's the easy part. However, test scripts and test logs, those are the two that we have access to for specific project, and then of course test artifacts associated with multiple builds, and we can also have ConOps, user manuals, interface documents, and then these two terms basically are to evaluation for risk specific to different aspects of the system. Okay. Testing challenges for space systems. Well, system init and startup image management, and if we have some issues with the timing constraint, init failure, and then right here we have switching to backup systems, and if appropriate bits are commandable. Okay. System safety. System safety and security, those are the two key aspects that really convinced me to actually go with the assurance case based approach, because that allows a very methodical way of looking at the system safety and security, and then divide up and dig down and make sure that our system can handle specific safety and security claims. Okay. Assurance cases. So what is an assurance case? For the uninitiated, it's basically a specialized instance of a general case argumentation, and then there's a claim, and then it can have subclaims, and then for each of these claims, we build this evidence to make sure that the system can handle that claim. Okay, and I'll give some examples as we move forward. Okay. For test design, the test design from the IV&V perspective, test team provides us with different artifacts. And if we go with the example which I mentioned earlier about automobile system, so before the car is ready for full-scale production, or maybe a batch of cars is ready for testing. Okay. All right. Could be one claim, right? And here is I want to emphasize on something, that when we set up for assurance cases, if we set up claims, how to make sure that we prioritize those claims correctly. Why? Because there is a lot of work involved in assurance case application. So if we end up picking up claims which may not be safety and security specific in terms of their priority, then in that case we may end up spending a lot of time on something that may not produce good results. So, so in this specific case, claim 1 and claim 2, as we can all see, is something, well, we can live without, right? But claim 3 is the one that I really want to focus on, and that's a test driver can drive the car along an intended course, and then we can have subclaims that the car will start, will stop, right? And so then we actually go through and build the evidence for it. So for the subclaims, we have the engine starts up, car can be stopped safely, airbag will deploy in case of an accident, and prioritization of the claims. That's the main thing over here that I want to emphasize on, how to prioritize claims from safety and security point of view. Okay. So this slide actually provides, what is the generalized way of the car startup scenario. So we make a claim that the car will start up safely. So there are a whole bunch of things that we may or may not notice, right? That the ignition control will not trigger if shift selector is not in the desired location. Okay. Then we provide evidence for that. And for example, that ignition control will trigger only when we have specific preconditions met. Okay. There's a little definition over here for complexity of tests. All right. So for the application of assurance case approach, you will see that the tool, the wonderful tool I talked about earlier, about the use of Microsoft Excel. So we have claim on level 1, After that, we divide them up to multiple levels of claims. Okay. For each of these lowest level, then we provide the needed evidence. Okay. Then we go through the documentation and make sure that there is actual evidence as well. After that, we can also weigh, and that's where usability of Microsoft Excel comes in, because we can use macros to come up with a scheme to attach weights and priorities for each of the evidence, like how important it is, in order to satisfy a specific level of claim. And once we have provided evidence for a claim at level 5, how does it impact then on higher levels, claim level 4, 3, 2, and 1. So this is where Excel has really helped. Okay, now few slides from here on, they're going to talk about test design, and I'm sure you guys are familiar with most of it. Okay, for a given test scenario, so we will have a test case, and there are a lot of different terminologies, but coming down to just the basics. What do we mean by that? That if we have a specific set of inputs, and then we expect the system to behave in a specific way for those set of inputs, and then as part of that behavior, what are the outputs? Okay, and we can build that for a requirement, which is pretty common and it's relatively straightforward to do. However, it becomes complicated when we look at specific claim that may not be associated with just one specific requirement, where maybe we have more than one requirements, and they may be in different locations and of the document, and also how the scenario will behave. Example for such groups of requirements is what? Especially when we talk about space systems, abort scenario, right, or safing response. Those are the ones where multiple aspects, multiple functions of the system, they may come up and respond to hardware as well as software issues. Okay, so here we are. For each of these claims, we generate a list of triggers. So if we say that the car will start as expected, then there are a set of triggers. Either they are human generated, or there are internal checks or events which are programmed by the designers. Okay, for each of the triggers, okay, then we try to generate the test scenarios. So here we are, trigger for the requirement, corresponding requirement, and then the type of data being processed. Okay, just a graphical notation that we for our system, here we had the science instrument, a controller for that, hardware aspect, and then the test environment. And most of the triggers over here, there were user or the ground commands. Okay, then for each of the given commands, the instrument flight software, it actually produced one or more hardware commands across this interface, and during this process we could use the test environment to provide responses to the system for a given scenario. Okay. All right, so here is the list of triggers. There could be what? Most of the time they are the external commands, and then internal and relatively small number of events, system events. Okay, and then we group these triggers, and then we look at the responses. So here we have now gone through what? That we looked at a claim. All right, for that given claim for a specific assurance case, we came up with the triggers, the system responses, and then grouped them in the order of their priority. Okay. All right, so here we are with the test design, validation, analysis, and evidence. So we talked about the test scenario, reference info, evidence info, and then observations if there are any. The idea is to actually use this approach to come up with any holes which are left in the test design itself that may not be verifying the system behavior fully as intended by the set of requirements. Okay. So in this case, I'm just giving some examples. What we were able to find is the incomplete arm and fire command and tests. Okay. Missing alternative steps in the board sequence. This was really, really important because once we updated the test design, it ended up showing some of the, I would say, shortcomings of the way the design was put together in case we had to abort a given observation scenario. Okay. Then for the command parameter verification itself, and then missing mode verification test. These are the general 5 different groups of findings that we had based on this approach. Okay. For the actual CSCIs, just to give you guys, that this was 2 CSCIs. They had around 250 requirements each, around 40 plus ground commands, and then they both had software hardware interfaces, the number of scripts, and then some of the, like the second with the higher level of test procedure embedded in the test scripts itself. Okay, summary. So assurance cases, they can help us, attack this test design analysis in a much better way. And by the way, when I talk about test design analysis, yes, this is specific to this presentation, that's true. However, we can expand that to requirement analysis. We can expand that to code reviews and analysis of the operational procedures that we put together. Okay. All right, so here is the future work that assurance cases, for analysis test design, test coverage assessment, automated mapping, independent testing is something that we have a really wonderful group of ITC folks. Steven Seeger is one of the members here. So with their help, we have the independent test rig ready, and we are using that to perform the testing. And as part of designing these independent testing, we want to utilize the assurance cases.